Lecture 12, Membranes. Setup, as usual, introduction, membrane material, comparison of types, fabrication and application. Membranes are thin, flexible structures which carry loads through tensile stress. The results are usually light, weight, efficient structures for enclosing small, medium, and large, mainly large spaces. It's a light structure, so large spaces. We do define two types of membranes. It's the tent structures, membranes stressed between fixed point. And by being stressed, we mean that the geometry of the surface deals with balance between forces at all places of the tensile structure, versus pneumatic structures, where the reinforcement comes by compressed air in the pneumatic structure, and by that balance the stress in the tensile structure. We do deal with three types of material: PVC, ETFE, and PTFE, fiberglass. The first one is the most simple and the most cheapest one. It has the downside of that it can drip by being flamed, and it's not transparent. That's also an aspect, but it's the most cheapest material for use for membranes, which is why we see a lot of these PVC membranes being used. And by being an plasticized PVC, it allows to adjust a bit to changes of forces and repositioning, which makes it a bit more flexible. And key aspect of this material being cheap in construction, it can be welded together. It's a thermoplast as surface, and this thermoplast surface allows you to have two layers, which we see later, and then being welded. It fixes the geometry. ETFE membranes, ethylene tetrafluoroethylene copolymers, wow, complex wording, is a polymer which typically comes in this 0.2 to 0.5 millimeter. It's a very light structure. It's quite resistant. It has an 85% light transmissions, and it allows quite good to deal with stresses, which makes it a good material for pneumatic structures, as we see here with the ice cube in Beijing. Yeah, that's where it is mainly used for, versus the PTFE fiberglasses. These are fiberglass layers which are reinforced with glass fibers, and with these glass fibers they're actually able to deal with higher stresses. And it's said that they can be used into -70 to +200 degrees Celsius, and by that having an expected lifespan of 30 years, are used in very extreme and harsh environments. Obviously a lot more expensive. Which brings us to the comparisons of these different materials. PTFE and PVC are mainly used as translucent or opaque roof structures. The PVC is getting a bit brittle over time, which then needs a replacement. Comparison of the types, thermal, or comparison, they say technology of tensile structures. Thermal insulation, very low. It's a super small, super slender material, so there's no opportunity to really have a thermal insulation. If you want to increase the thermal insulation, you may have to have several layers, maybe with an infill to secure that there's less heat exchange to be able to generate a certain U value, but you see a U value of 3.0, very limited. Acoustics, now yeah, it's actually like a drum. You have a pre-stressed structure. If rain hits this, you obviously get a noise. So acoustically, these tensile structures are always a complex one. You may think about adding weight, but then the light structure disappears. So that's a downside. And then there comes the fire, which I need to show here as well. All these materials are flammable, or at least kind of flammable. You may have additives to reduce that, but it's not a very valuable material in the means of fire. And the downside really becomes complicated if the material itself starts to burn, it starts to melt, and if it's melting and starts dripping, then it really gets something which you need to take care of in your design, that people are not injured by this as a situation. How to fix a membrane? You somehow need to get the forces which I talked about earlier into the structure. And the simplest one, as we know this from fabric, is you stitch it. So you see these stitching lines, which means you have an overlap around a certain rope or whatever, and then start stitching the fabric versus the welding solution, which is done. You again have this 2 layers of material, and then with a heat iron, certain iron, you heat either in between or on top to weld, to liquidifies the outer surface of, for example, the PVC, and then weld it together as a system. Application versus application which we see in construction. This is a super large one, the Millennium Dome in London. Obviously, by that size and not being transparent, it's a PVC structure. And you also see the dimension is limited, so they have these additional ropes which then take the forces of this structure. This is an ETFE cushion facade, Allianz Arena in Munich, and you nicely see the inner structure. You see the handrail which goes up, inner structure, so the translucency of this is used in this system, air pressured, so cushions with air pressure which create this certain shape. Another ETFE cushion solution. This one being having a certain print. With this print, we have an inner and an outer cushion, and in between there's an additional layer, and this additional layer could flip depending on the air pressure to the one or the other side. And by that, with having this imprint, may block off any transparency or allow light to go through this system. You see all the pipes there controlling these different types of air pressure. And then this one following the same setup, not having this inner layer which flips from both sides, but being used as an outer facade shading and covering outer facade of a nice building in Madrid, if I'm remembering correctly.